Okay, welcome everyone in the room and on Zoom to the NLP Meetup at Melbourne Connect. Before we begin, I would like to acknowledge the traditional owners of the unceded lands on which we are meeting today, which are the Wurundjeri Woiwurrung people and the Boonwurrung people. I'd also like to acknowledge the elders of all indigenous nations, which have been and are so instrumental on the path towards reconciliation. I would like to recognize the unique place, the Australian landscapes and waterways on which we are here, and of which the Aboriginal and Torres Strait Islanders communities are the original owners and custodians, and they have been this with a continuous connection for over 60,000 years. I also want to acknowledge the enduring cultural practices of caring for country and pay my respects to the elders past and present, and particularly acknowledge the importance of Indigenous knowledge in the academy. So as a community of teachers and students and researchers, we are privileged to learn and work here on this land with our Indigenous colleagues and partners. And with that, I would like to introduce our first speaker tonight, which is Ed Hovy. Ed is the Executive Director of Melbourne Connect, this very nice building that we are meeting in today. He is also, in some sense, our host and paying for our food and drinks. So thank you very much, Ed. We appreciate it. In addition, he is a professor at the School of Computing and Information Systems here in Melbourne, and also a professor at Carnegie Mellon University in the US. He has served as a program manager at DARPA, where he managed large funding schemes into natural language processing and data analytics, common sense knowledge in particular. Ed has 3 doctorates, a real one from '87 from Yale, and 2 honorary ones in Madrid and Antwerp. He is an ACL fellow, a AAAI fellow. He has published hundreds of papers, but not only hundreds of papers, but hundreds of influential papers, where he's tens of thousands of citations speak to. And today he will tell us about what he thinks about the future of NLP in talking about NLP in the world of generative AI. So please take it away.
Thank you, Leah, for that nice introduction. Hello, everybody, and welcome to Melbourne Connect. It's a pity that the weather is so crappy, and today is going to be the same kind of, but it's less windy tomorrow, and also Friday, because when the sun shines here in this kind of temperature, it's great. It's a lovely place. So unfortunately, it's just what it is. So please come back soon and come and visit us again. As you'll see tomorrow when we're upstairs there's lovely food and coffee and all kinds of things, and there's lots and lots of interesting things that we try to organize here. Events like TED Talks, TED panels, cross-disciplinary things, all kinds of hackathons, student events, industry events, pitch fests, a lot of stuff happening there. The idea is to try to make this a focal point for the whole city of Melbourne for sort of intellectual academic endeavors with a sort of an industrial company type outreach. Because the university isn't just an ivory tower, right? I think that's why we're here. We believe there's a connection between the ideas you get on the university side and the actual practice, making a change in society on the other side, which is the main reason I came here for this job, otherwise I would have stayed in the States. So today, of course, everybody wants to talk about generative AI and ChatGPT. So I'd like to just share a little bit of thoughts on that, if that's okay with you, right? And then if it's boring, just tell me move. And if it's okay, if you tell me shut up, I go away. I don't have to talk. My wife says I talk quite enough in the world, right? So here is, I just want to see why it's not working here. There. Okay, so I'd like to first, I hope, there. I'd like to first just talk about what NLP, just like 2-3 sides of the past. And then what happened last year, almost exactly a year ago, and how that's affected what's in the future and how it plays out for companies and industry specifically. There's lots more. I have a talk that I give like twice a week now for the last 5 months to industry and to the university on what is ChatGPT, and a little bit of that is here just in case for interest. But there's lots of different avenues in education and in different kinds of industry, in construction and biomedicine and public administration and so forth. And everything has its own story. So it would be fun if you have interest in any of those, and we can talk about that later. So this is Melbourne Connect. I mentioned what it's about. There's about 3,000 people in the building. There's an art science gallery. There's a kindergarten upstairs. There's all kinds of things happening here. So if you want to know more, we can tell you more. There's a whole bunch of people here. So if you look at NLP, when it started in 1962, the first ACL conference was 1962. NLP, the first sort of beginning of machine translation, was slightly before that. Joshua Bar-Hillel and some of the others were talking about machine translation. There were some companies, the Georgetown Project and stuff, started in the late 1950s and 1960s to do translation for the Air Force. It's one of the oldest sort of mainstream NLP applications, but information retrieval, people don't know, started at roughly the same time, with people saying, how can we access and fix the library problem so we don't have to go through these lots of little cards? And there's a guy named Cleverden who did the Cranfield experiments at Cranfield University, who showed that you don't have to just have a few index words. You can pick up any word. You can even include function words like the and to. And when you have the vector space approach that Salton and people at Cornell designed, then you could actually get much better response. As a result, then the IR and the librarian community split off, and SIG-IR started, and it became like the mainstream IR thing, and out of that came TREC, and that sort of history came from there. At the same time, more or less, speech recognition came. And so people were trying to model the articulatory channel and how you make sounds to say a 1, 2, 3, they had 10 digits, and it was a big mess. And then came the hidden Markov model, Jim Baker and things at CMU, and they just trained the systems, and out came this beautiful result. And from then on, they just saw you have got to learn. So they were the first guys in language technology really to say machine learning is the thing that works. And the vector space approach, the representation that we all use in some sense, now it's embeddings, right? But it could be just word vectors and things. That came from IR. Those two things were developed by those two sub-communities. And then in the machine translation statistical MT of 1989, 90, when the IBM group brought machine translation in to mainstream NLP, they brought those ideas in. And there was the statistics wars for about 2-3 years until everybody realized we can't build rules anymore, forget it. The whole expert system, rule-based, nice Eurotra, little syntax and semantics rules and stuff doesn't work. That was the argument, put harshly. And so everybody switched over, and from machine translation then came all the other approaches to information extraction, which used to be finite state machine, and now it's learned finite state machine, and text summarization and question answering, etc., etc. I put up a few milestones just to show a sort of a shape of what happened. And if you push this forward, and if there had not been the revolution that we saw a year ago, we would have been in this world, and we would just have been pushing these things forward and more, right? We would have been doing social media, and we would have been personas, all kinds of things. We would have been developing, all of us together, and developing data sets and evaluation metrics, and we would have done happily for the next 25 years, we would have done exactly the same stuff, just more and more bifurcated. And the older ones, like information retrieval and speech and machine translation, would have matured out and just stopped, because they're basically done. They come to a level where you just have functionality. But then came OpenAI and the whole revolution of the chatbot, right? And that just killed everything, and a lot of the work here just died. You may be working on it still, but in my view, it's dead, it's gone. And a lot of PhD theses students went into the depression. They had before chat, the BC, and then they had depression, and they have after depression, AD. Now they have the future, and they have to redefine what they're doing. And so it's interesting to sort of wonder, what's the difference? If you look at, say, a representative of a real big system, big success system, like Watson in the old days, in the old paradigm, took 4 years to build. It had a lot of engineering in there. It had about 104 modules, each one for weather, and one for geography, and one for poetry, and one for this and this and this and this. And it took a lot of training and stuff to build up the system, and it had a big success, right? And then IBM sold it for $1 million, another $1 million to put knowledge inside. Now the new paradigm is just a large language model that has all sort of starter knowledge. It's read a lot of the web, it's all in there. So you still have 4.5 years to build the first one, or sort of a little bit more. It's not clear exactly how long they took. And then you put in, but a lot of knowledge is already there, right? And so now you can start playing with it. You don't have to be an expert. It's still English to English, but you can actually program this thing. And people are increasingly talking about prompt engineering as a kind of programming, the kind of functional language that you put inside prompts. So you can actually get certain kinds of behaviors that you can almost program this thing in English. And a lot of people are doing that, especially in companies, but also in schools, in places that people don't traditionally program. So that's part of its phenomenal uptake to 100 million people in about 4 months. No other single thing in humanity has ever gone that quickly, from 0 to 100 million people in that few months. No thing in ever the history of humanity, and it may not ever happen again. We're living in a very strange time, and we're fortunate and privileged to be in the middle of it. We, NLP people. Okay, so clearly this thing wins. And so clearly, as a result, AI is just taking off. And here's a whole bunch of studies from all the consultant companies and stuff showing a bunch of numbers and the impact on the economy and so on. And I can send you these reports if you want. The top right-hand box of $370 million is an estimate of the annual impact of this kind of technology on the Australian economy alone. And the Australian economy, as we know, is tiny compared to the world economy, but it's a big impact, right? So we have to ask ourselves, what is this thing? Why does it do what it's doing? And given that, and given an understanding of what that is, where is it going? And how do we apply it in our sort of shared context of interested in the technology, the techniques, the theory, and also the applications in industry? That's why we're here now, right? Okay, so give me a chance just to give you 7 or 8 slides on how this thing works. Those of you who know how it works, I beg your forgiveness. Please just go to sleep or go have a Coke or something. There's this interesting cola around the corner there. And then it'll be sort of simple, right? But for those of you who don't really have a good intuition for how it works, this I found very useful to tell people. Is that okay? Right? 7, 8 minutes or 6 minutes, okay? If you look at the evolution of machine learning, right, in the older days, people built expert systems. And you had a thing that did a medical diagnosis, and when it made a mistake, you could trace its reasoning and say, aha, it said this because this factor, I forgot some factors, I did this. You had this whole decision tree. And that was a good paradigm, but the world is not that simple. So in the sort of 80s, 90s, people said, machine learning, you've got to learn, right? And so the whole paradigm of building a data set and training a machine to do this took over for a number of applications, as we know. It means then that you don't get a 100% answer or a 0% answer. You get a sort of range of answers that are sort of good and sort of bad and sometimes not. You have to characterize all this. You need an evaluation paradigm, but you can actually do a lot more with this. It's more robust in some sense. And that's what happened here for sort of machine learning. And today there may be, let's say, 100, 300 or so families of machine learning algorithms that you can apply. And typically, because the machine learning guys don't do their work properly, you don't know which algorithm is best for your problem. You have to sort of try a bunch of algorithms, as opposed to saying, here's my data size, here's my data skew, here's the number of variations I have and stuff. Therefore, I must use algorithm 15. You can't do that today. And if you ask the algorithm guys, the machine learning guys, why can't you do your work properly so that I can do this? I don't have to go and play with all the algorithms. They get angry and they say, we like inventing new methods. We don't like systematizing what we're doing. And so you have a glorious fight on your hands. But that's essentially the position. Now comes neural networks as a subtype, a different, slightly different architecture subtype of machine learning, in which it learns the data and it learns the representations and it learns to do the thing all in one, which is great. It simplifies your life, right? You don't have to choose models and you just throw the data in. The trouble is you don't know what's inside. It doesn't speak English. It speaks embeddingese or neuralese, and it thinks like an alien. And so that's our problem. It can't explain itself, but it does better than anything else by about 10% on average. So now we have this problem of what we do, right? So the role of machine learning, training, testing, and then usage we know. So now the simplification, just the simple form of what's going on. Please forgive the simplicity here, but this is sort of useful for some people. Okay. If I give you a simplified problem, here's a flower, the iris. There's 3 types, the setosa, the virginica, and the versicolor. I give you a flower, you tell me which of the types it is. And I just give you, I don't care color, I don't care size and things. I'm just going to give you 4 measurements. The petal length, the petal width, the sepal length, that's this funny little leaf in between, and the sepal width. So I'm going to give you a table like this. And here you see, there's the numbers. And there you see, column 5, you see all the types. And you look at it as a trained data scientist and you say, oh, I can see what's going on. I must just ignore columns 1, 2, and 3, column 4. If it's short, it's one thing. If it's middle, it's one thing. And if it's long, it's another thing. Yes, yes, right? That's because we know how to work with numbers. Okay, so that's trivial. When you go to a machine learning algorithm, you're asking it to do that analysis, to learn that pattern, and it's seldom that simple, right? So if you do this sort of analysis, if you show the little lines here with colors, you can see on the right hand, the fourth column is nicely. The blue is the short and the middle is the yellows. You see the separation beautifully there. But you can see there's sort of some mixtures of colors too. Mostly the data has much more mixtures. And so your machine learning algorithm and your representation has to be strong enough to capture mixtures of things. Okay, so now you say, okay, how do I learn with this in a neural pattern? Well, let's take that table. Let's take just 2 neurons. I wire all the neurons up to each of those 4 values. And I have a little combination function in the middle. The combination function computes 1 value and pushes it upstairs. There's a simple linear combination function here with 4 parameters, A1, 2, 3, 4, that I have to now learn. And at the top, I have a classifier with a softmax there that just says, and I know now, right, A4 must be equals to 1, and A1, 2, 3 must be equals to 0, because those numbers don't mean anything. So it's going to learn through the back propagation to push A1, 2, 3 down, and push A4 up to 1, and then my thing is simple, right? That's how the whole back propagation thing works. Of course, for a transformer model, I have a sort of large, up to 50, 100, maybe more nodes, and I have about 12 or 20 layers, and I do the full combination, but I can do all kinds of architectures, and I basically get that. Right? Everybody knows. So why is what happens in the middle, the actual interesting magic here is not the structure of the thing, is the internal function. If you just put a linear function in there, like they did with perceptrons and things in the 70s and 80s, you can't do much. But if you put a non-linear function like a tanh or a sigmoid in there, then the magic happens. What happens? If I put in 3 features, red, yellow, and blue, and after training, I'm discovering that, in fact, my yellow is the important one. I want a lot of representation space in my embeddings there for yellow. And every little small piece of yellow difference is going to mean something for me. But red and blue, I don't care. I can reorganize things so that on the output side, I can stretch. I squeeze red and blue down to nothing, but I have a lot of yellow in there, right? The beauty of embeddings is I start with a random encoding of some micro features, 100 long or 500 long. I don't know what they mean. They don't mean anything up front, but through periodic training and back propagation, they in combination gain a meaning. They gain a something, and they say, I'm part of the yellow thing. I'm influential here. Put me in the middle space. This is going to, put me here where there's a big climb on the nonlinear function. Whereas if I'm not, put me on the edge spaces, squeeze me out because I don't mean anything. That insight to go into that nonlinear function there is what unleashed the power of this architecture. So then when you have something like this, you say, good, now how do I learn with text? So Hinton and company did a lot of experiments in Toronto, and Ilya Sutskever now from OpenAI, right? He worked on the generation part. But what do you do with text, right? So I give you a bunch of sentences. Let's take 20,000 sentences here, and we blank out the middle word. And I ask you, what's that middle word? And you look at it and you say, well, it's got to be platform. What else could it be, right? How do you know that? Well, I'm looking on the left-hand side. I have words like station, so it's a trainish thing. And I have word like the, so I'm looking for a nounish thing. And I have words like waiting, so it's a train, it's a station, trainish thing. And I have platform, something 9 3/4. There's only one phrase I've ever seen that way before, etc. I'm expecting out of my left and right feature cloud that this word is platform. Said differently, the definition of the word platform is this cloud of, let's call them micro features. They're sort of syntactically, semantically, sort of something-y, right? They're not exactly syntax and semantics and lexical, but they sort of have the features that combine to give this thing. So I do this for all, let's say 300,000 or 400,000 words in my English lexicon expanded, and symbols and stuff like this. And that's how I get the definitions. That's how my embeddings then become trained. So when I pick up a word, inside that encoding there, it's saying, in my left is a the, and on my right is a trainish thing, and on my left is a this and this and this. And so I'm platform, that's my spelling, but this is my definition, right? That's the sort of intuition of what's going on. So with these sort of micro features, let's call them that. So when you do this, now you can build lots of and train lots of architectures. Here's a whole bunch that have been built of LLMs that have been built in the last 5-6 years, right? You can see a lot, starting with BERT, which thank God Google made available. And now, you know, thanks to Meta, they made Llama 2 available. So it doesn't matter how many people like OpenAI are not open or sort of selfish and greedy, somebody's going to make things open and the rest of us can work on that. So that's what's happening there. Now, you say this is a passive thing, right? It's not chatting, it's just got the knowledge. You put the stuff in, you get something out. But you want to make it speak. So Sutskever did a lot of work, him and a few others, on making the speech come out, right? Put a chat loop on top. So basically, you give a prompt, you give a bunch of words, you pick up some of those content words, you match them into this network, and out come the similar words that match well with these, right? It's got predictions left and right. Given this word and this word and this word, what am I expecting most probable to go to my left and right? I give you little phrases. There's a bunch of them. I pick one, I output it. I say, okay, I've got a few new words now. Let me take some of these new ones in the context of the old ones. I pick some more, and I keep going, and I keep going, and I keep going left to right, and I just keep going. And if you look at GPT-3, the way it wandered all over the place, there's no sense of coherence or anything. It just said all kind of rubbish, right? And just hallucinated, put things together in a crazy way, went all over the show. When ChatGPT came out, and then 3.5 and ChatGPT 4, they tightened that up, that coherence a lot. So there's macro coherence guidance, sort of a template on top of the little sentence templates that guide you, that say, okay, don't just go this way and this way, stick to the point. And in fact, there's even templates that sort of say, you have a list of things, make bulleted items or make numerical items, right? You have to, it's puzzled me a long time how you can do this. When you write a paper, you don't just go left to right, like my daughter does. She doesn't, and she goes, who knows where she goes in topic space. When you write a paper, you plan your paper, and then you fill it in. This thing doesn't. You can play with it, you can ask it. Everybody, they all say, no, this thing goes just left to right. I asked Slav, what's his name, from Abu Dhabi. He showed me the one that they'd built there in the MBZ University of AI. They built it from scratch. He said, no, you get this coherent behavior if you get enough stuff in and enough coherent training data. It's learning not only the little word patterns, but learning patterns of bigger combinations of micro features to sort of guide the structure of coherence out there. So there's a longer discussion in there, but it's doing that sort of thing by itself. So that's kind of magic, but it's kind of interesting, but it does give you a certain coherence and consistency. So what do you have? Basically, you have a machine that has just ingested a lot of English and learned for each word its little microfeature clouds predicting what's left and right. And so that when you give a bunch of words which are translated into their microfeature clouds, you can combine them and pull out some more words and then get little phrases. And then when you do this left to right continuation tiling top on top expansion, then you get the generation, the chat loop. That's what you have. That's what this thing is. Nothing more. Okay. So here is now you have this very clever thing that looks great, but it lies to you, right? It has no sense of logic. It can easily put together two pieces that are correct, but that together are incorrect. It wouldn't know. How would it know? It's not checking anything. There's no logical consistency or anything like that. There's no it there even. There's no ego. There's no self. There's no sense of goals or anything. It's just a thing that matches and continues. So all this hype and all this nonsense you read about it wanting to take over the world is just nonsense, right? So one has to know that so that you can tell people, it's up to us, NLP people, to tell the world out there, don't be afraid of this machine. In its current form, it is just a pattern matcher with a continuation loop. That's all it is, right? It may be that people are putting other things on top and connecting it into bank accounts and all kinds of stuff, but that's the future. That's not there now. Okay, so you can still use this thing as long as you understand what it is if you use it responsibly. Of course, now you can test it, and it has all kinds of wonderful behavior. You look at the blue bars, that's the test of ChatGPT 3.5. The green bars is ChatGPT 4, and it passes the law exam and does all kinds of wonderful things. Yeah, sure. And so people get scared, but it just shows you that the law exam is actually not a test of anything significant. It's just memory. But we knew that. Any intelligent person knew that law is not an intelligent thing, right? It's just got to memorize. It's like medicine. It's not intelligence, it's memorization, right? So, you know, this thing is good at memorization. So great. Now we have to train our students to not just memorize, but to think. Is that so bad? Is that so terrible? There's an ongoing discussion among the university here, even here, between people who say, no, switch this thing off, you're not allowed to touch it, versus people who say, you need to think what you're training your students to do. Train them to think. Don't train them to memorize. Rejigger your whole thing. It's not so easy for some people to put their mind around, right? They feel threatened by this. It's going to happen. It's just going to happen. We're going to have higher productivity and better response, better results by training people to think and using the machine to do the simple pattern matching, the simple memorization, right? Then it's our job to look for other new things that we could do that machines cannot do by simple memorization. So now let's skip the vulnerabilities. Now we get to what happens in the workforce. Okay, so when you go to construction, for instance, so I recently was in a meeting in the Melbourne cricket ground there with a big construction expo, and then I was on a podcast with construction people, and then another meeting and a panel with people from public administration, about 150 people from all kinds of branches of Victoria government, and then another thing with, I don't know, energy, engineers, Australia engineers, top, sort of management meeting stuff. Everybody has the same sort of question, like, should I use it? We feel we should. How do we use it? We have no idea. Is it dangerous to use it? Well, maybe not, but the fancy people tell me it's dangerous. Is it going to leak my data? Who knows? Do you trust OpenAI? Do you trust Facebook? Do you trust Facebook? Of course you don't trust Facebook. Do you trust OpenAI? Of course you don't trust OpenAI. Why should you trust them? Why? Because they give you a little box saying, I'm not going to learn from your stuff. You trust that? Please, okay? Okay, maybe you do because you're Australian, but let me tell you, the world is not worth trusting, right? You can't trust things. So you have to do something to protect yourself. But what exactly is that thing and how do you do it? Those are the questions that industry keep coming back with when I talk to them all the time. They want to know that. So first, let's look at what people are actually doing with LLMs today. If you go to this website here, this questions about LLMs there, the sort of 1 million database of questions, you see here are the kinds of topics that they're asking about. I hope you could read there. I can't really see so well, but there's a lot of stuff about software coding, and then there's questions about NLP, typical NLP applications like QA, and how do I make it read and summarize and do all this kind of stuff. You get a sense of what the world is trying with this machine and what the world is still holding their hands off and not doing, right? So you can do it this way, is a different way from an IBM study that came out earlier this year. For IT professionals, there's a lot of interest in there. For instance, ANZ Bank, just down the road here, I visited them and they've been here. They were here on Monday morning. We had a breakfast meeting with about 40 CTOs, and they were here too. And they say, an interesting thing, they say, we have about 11,000 attacks, cyber attacks a month, where people try to break in through emails, to fake passwords or something like this. We have a team of about 13 people who handle these. And when the attacks penetrate far enough through all our safeguards that we see them, oh my God, we got to fix that. We used to then analyze and write some code. Now we just give it to ChatGPT and it writes the code. Of course, it's not perfect, but then we fix that code. They've improved the throughput of their work by about 32%. They're 1/3 faster, and they cut out all the boring sort of first draft writing. They love this thing. Okay, and that's in cybersecurity. That wasn't the first thing you might have thought people are going to use ChatGPT for. No, there's people who do sort of data engineers, of course. There's developers and data scientists who sort of use this thing to design for them certain procedures and stuff like this. There's security professionals and things, but there's marketing professionals. There are people who say, I run an operation and I have 4 people sitting there answering the phone for all my customers. And I have to train these people a long time because they need to know everything about all my products and all the little details and stuff like that. However, if I give them ChatGPT, which I've trained up with prompts and with RAG on the side, right? then I don't have to train them this much because they type or the question goes in and the answer is there for them. I cannot put ChatGPT directly to the customer because A, it doesn't have any customer smoothness. It can lie and hallucinate all over the place. So I need to have a human in the middle, but I can certainly use it to give basic information. And as long as my customer service agent knows enough to say, this smells fishy, let me ask the question a different way, you can actually improve the quality and the speed of your throughput by a lot, right? That's a whole different game, right? So that's a very interesting use of this sort of technology, which you might not have thought in the first place. If you look, let me tell you one more. My EA, my secretary, EA, whatever it's called here, she loves this thing because now when we have the minutes, when we have the meetings, the steering committee meetings of Melbourne Connect, she used to sit a whole day and take all her notes and things and write up these beautiful minutes. Now she just runs Zoom. She records everything that's said. She transcribes it into text. She cuts up that text and she pushes it into ChatGPT and says, summarize, summarize, summarize. She gets all the stuff, she pastes it together, she changes speaker set, she puts the names in of the people. She's finished. Takes her 2.5 hours, not a full day. She loves this machine. And I cannot tell the difference. Not that I read every word of minutes, right? But she cannot tell the difference, right? So there's all kinds of unusual, crazy little opportunities there. And the message seems to be try, because it's English to English. Anybody can play with this thing. And as soon as people are not afraid to try, give them the freedom to try, but don't actually make it touch the customer and don't leak the data out. Those are the messages that always come through. So search your company data is a major thing that people are doing. You put your company data in a RAG, in an extra little database here. You run Elasticsearch or an IR engine on top of it. You put your prompt in, it pulls relevant stuff out, it enriches your prompt, it goes through and out comes interesting stuff. That's a very useful and common functionality now. We have one here that was built at the University of Melbourne. We've got two at the university here, both of them on Llama 2. One of them does exactly this for university courses and for student needs and for requirements, all kind of stuff. It does that. Create new content. The content creators create ads and stuff, especially when you couple it with pictures and things and movies. Then they like, as a starter point, give me an interesting, I have a student working on creativity where we look at how you can generate variations of something under certain dimensions of creativity, quote unquote. And you can guide it in picture space or in text space. The summarization, anything where you get text in and text out and you do something with that text in between, translation, summarization, QA and stuff, it's good at that sort of things. It knows how to find word clouds, match them and give you recombinations of this. And then of course, the software. So here's an interesting experiment. It was done at MIT a little while ago by Noy and Zhang a few months ago. It's in Science. They had two groups. And they said, write a paper about your expertise, write one page. And either you use Overleaf or you use ChatGPT. And you write your thing, and then you look at the result. How quickly did you get it? How good was it? Right? And so then you swap the two groups around. And again, you write. Now the ones who had chat, now they write with Overleaf, etc. And you see the graphs there, the time, right? If you just used the Overleaf thing, when you use chat, you go much faster. The quality goes up much more. Those who are poor authors, when you have chat in their pipeline, they get helped a lot by the quality of the text. So in text operations, it's actually a very valuable thing. We need to stop. 5 minutes, okay. So I have a few more slides along these lines to give you case studies, because I don't know of any systematic overview here, but I want to, maybe I shouldn't say this because it's sort of insulting to Australians. Anybody care if I insult Australia? No? Yes, it's okay. If you look at this thing, which is an IBM study on innovation adoption, which was published last year, the blue means how well trained is your workforce in innovation, in technology, and digital. And the purple is how much are you taking it and using the new stuff. So you see some countries like Singapore, well-trained, good adopters, right? You look at India, very well-trained, sort of a lot of adoption. China, right? And you look at Australia, reasonably well-trained. No, sorry, I've got this the wrong way around, right? The exploring AI, exploring but not doing. Sorry, it's not well trained. Is are you doing it, and how much are you exploring? So Australia is very conservative in the doing, is much less doing and much more exploring still than anybody else, except this one, except here, UK. So that conservatism with respect to chat and digital work is holding the country back, I think. And it's a pity. It's a great pity that that's holding the country back. So here's some numbers about this. There's this. So I think basically what the message is, take the thing that you have, this free or almost free ChatGPT 4, better than 3.5 or 3, and give it to everybody in your company and play with it and allow everybody to play with it and have a periodic meeting weekly or monthly or bi-weekly to say, what did you try? What works? Share it with us to see what you can do. That's one line, and just find out. On the other line, on the privacy and security, don't trust OpenAI. Don't trust any of these things. You can pay Salesforce and put it on the Australian cloud and maybe it'll work for you. But you can soon, you'll be able to get smaller and smaller ones where you can put more and more of your company data inside and you can run it yourself with a moat around. So all the banks, all the biomedical people, all the defense people, they're all going this way. I read 3-4 days ago about the speed up of 131 times, 2 orders of magnitude in training and usage by a group. I think they were in France. I just have to go and check that up. There's a lot of work on making these things smaller and faster and equally powerful. I think before the end of the decade, we're probably all going to have our own personal version on the cloud, accessible through our cell phone. And it may even listen to all our conversations if we allow it to, and encode that and put it in our own personal, sort of a personal amanuensis thing. I think it's going to be a really interesting time. I think we've only seen the beginning of what's going to happen. I think we should just not be afraid, and it's up to us NLP people, to tell the world, don't be afraid, try it, play. Okay, thank you.